Hi, my name is Mohammed,
My name is Saad.
My name is Saleh.
And my name is Abdul.
and today we're going to talk about our city horizon. Imagine a city without roads. Roads take up this big area of our city. You only have a small area to walk. Now, imagine if you could utilize this whole area to do whatever you want. One other problem we face today is that the Department of Transportation accounts for 75 billion US dollars.
Another problem we face now is how to achieve sustainability in our future designs and improvements that we want to make or implement.
At a certain point of the year, we as a society face a challenge of proper and sufficient distribution of hot and cold water.
This is the side view of our city. Our city will have buildings equally spaced, and they'll have a ground floor and a floor underneath. So underground we'll have our whole transportation system, where the pods would be able to travel. So the concept is similar to the Hyperloop, where you see so it will levitate and travel at really high speeds. The way we establish this is that each building has a solar panel, so it's kind of like a generator, and then this generator would transfer electricity between buildings. This would create a magnetic field around this electricity around this wire. So if we have different directions of electrical field, like on the top and at the bottom, this will create a magnetic field that's in the direction inside the board. So if you want the pods to go in the direction of the inside the board, we'll have it going. We'll establish this direction. Now, if you wanted to go outside, we'll just have an opposite direction where it would go that way. So what I'm trying to say is that we'll have a dynamically changing electric field. So if you go down to the top view, you can see that each building is connected to its neighboring building. Like to transfer electricity however we want. We can change the direction as we want because each of them are generators. So if I wanted to go in another direction, I'll just have to change it according. Now this changing of electric field would be determined by a centralized unit that would find the efficient algorithms to find the best route for the pods to travel. So this would avoid car accident. It would find the best route, and this would be done at really high speeds. Now the ground above, that's where right now when you go outside, that's your ground above. But underneath, no one's allowed to walk there. We only have the transportation system there. This transportation system is created by a byproduct of this electric field that we've established. So you're saving resources, it's cost effective, and you have a really fast transportation system.
This is a small model of our project City Horizon. So these are the buildings with solar panels embedded in them. And as you can see, there are no roads on this first floor. Everything is walkable. And this really eliminates all the issues with roads and cars we have nowadays. So each building is equipped with leisure facilities and restaurants, and they will also obviously be residential. So this is our ground floor where all the traveling will be done. So as you can see, these are the pods which are levitating, and they move in multiple directions. So this will happen by an electrical system which is running through these grounds over here, which will help levitate these pods. So our pods will be run by an automated system which will help designate these pods and help them find the best route. So over here it might look that they only move linearly, like from this building to this, the front one, but actually it can go from this building to another building, which is right across, which is in another side, in another area. So since our project will be very big, there will be multiple buildings all around, and these pods will be able to arrive over there safely. So our automated system will help direct these cars in the best and most safest efficient route, and this will help save time. And also this area will have no pedestrians, so there will be no chances of any crashes happening with any pedestrians. And these since we have a automated system controlling these pods, there will be no chance for these to crash either.
So this is the PSSE model we came up with for our city that's based on 6 different units or buildings, and each building acts as a generator and a load itself. So we assign specific values for the generators, and the diagram that the PSLC power flow diagram that we came up with shows that each generator produces some power, and then power is used for the load itself, the each building, and then the byproduct is sent to the transportation system so that it can produce the electromagnetic field for the transportation and the pods to levitate. And here we can see that the power flow report can be generated for each bus and tells us what kind of power and how much specific requirement we need for the control system to work smoothly without any flaws and malfunctioning.
One, go.
So we would like to design some more units like this. This is the World Trade Center in Bahrain. So these are some airfoils in between, and this generates more electricity, which would help increase our sustainability for all our buildings.
So now to tackle the important issue of HVAC, heating and cooling in our buildings, which we're doing in our design. So what we're decided to go with is basically dividing the system into two units. And just to get an overview, what we're doing is that this is the design which we'll implement in one building, and the whole of the system will be connected to the central automated hub, which is also controlling the transportation system of the whole city. So this will just be another addition to the system. I think it will be easily able to control the heating and HVAC of each of the buildings that we're gonna introduce. So what we're basically doing is dividing just for your ease of understanding, we're just gonna divide it into two units, Unit 1 and Unit 2. And to notice here is that the main components in our design are the heat exchanger, the air handler units, the fan control units, and the cooling tower and the boiler.
So the first unit basically is it takes in water from the supplier, goes through the manifold that diagnoses and controls the amount of water we need for the customer and for the city. So the manifold then sends the water to the implemented valves and pumps. The valves controls the flow of the water, and the pumps then pushes the water to the designated component we need the water in. So as you can see, there are 3 pumps. The first one pushes in the water to the unit that's just before the boiler. The second one goes basically straight through the chiller, and the third one is to the whole system, going through the whole system and back to the heat exchanger. Once we let's take this pump for a second. This pump pushes in the water to the chiller. As we all know, the groundwater is basically around 10 degree or a bit above that. So it chills down the water more according to the customer need and sends it to the chilling tower that then sends the water to the main system, the buildings and stuff. And going back to the first pump, the water in the sub-unit we have here goes through the solar panel using valves, and one part goes to the boiler. The solar panel heats up the water that we have in the system to an optimized temperature, let's say room temperature, and then sends it to the boiler, back to the boiler, where the boiler is powered by underground generators. These generators are on the same level, the underground level, as the transportation system, so the public won't have access to it and they won't have to worry about any problems or malfunction that occurs. So they basically have nothing to do with this control system. And as I mentioned earlier, all the thing is controlled by the separate department that just takes care of the heating and cooling of the whole city. So the boiler and the underground generators, they basically need less energy because the water is preheated by the solar panel, so it uses less energy, and then the less energy loss. And then Hasib can tell you what the whole other part does.
So as you can see from one of the pumps, the water, as he explained earlier, one of the water is going to the chiller and cooling tower too. So what we're doing here is that the cool air from the cooling tower will also go into the building for the atmosphere control, and plus the boiler here is for the boiling water, for the boiling water, but as you see there's a steam boiler here as well. So this will be to control the humidification of the building. It's because we're doing both the cool air and the hot air from the boiler, and you can control it from each individual unit into the building. So another important thing to notice here, there's another air handler unit here. So the water from the steam from the this boiler is also going to the handle unit, and then it also controls the flow, which is again done by the main hub. So it again distributes the hot air into the building. Again from here there will be another air handle unit which will control the flow into the cool air into the building. So here we go into the heat exchanger, air handle unit, and then into the building. And just to add on that, for what we're doing with the heat exchanger is that a hot water goes into the heat exchanger and then returns at a lower temperature. So what we do here is we exchange heat with another industrial material, substance we can use that is good for heat absorption and minimizes waste, I guess. So for example, that we've chosen here is glycol. So it absorbs heat from the water, and then again another important part, air handler unit, which distributes the heat to the building and then returns to absorb more heat.
Yeah. Moving on to the last part, that's not a big part compared to the unit 1, but unit 2 is basically it uses the end result and it supplies it to the AHU and throws the water to the FCUs. That FCU controls the water temperature towards the current requirement of the customers. So for example, if we need more hot water in the system, the FCUs control that and sends it to the main buildings we have implemented. Or if we need more cool water, the FCUs do the same. So it adjusts accordingly towards the needs of the customer.
Thank you for your time. We hope our project meets your requirements.